So welcome back guys. Now let us try to understand the one-on-one relationship between a physical page and a virtual page for a process. Now as the name suggests, one-on-one relationship means that if there exists a virtual page, then there exists a physical page. So remember, we equate virtual addresses as keys and physical addresses as lockers which have some data in it. A virtual page is a collection of 4096 keys, right? Why? Because we already know that the number of virtual addresses in one virtual page is 2 raised to the power 12, which is 4096. And each of these keys unlocks 1 byte of data in physical memory, which means that each virtual address provides an access to 1 byte of data present at some physical address in main memory. So remember, here key is nothing but it is virtual address, and virtual address provide you an access to exactly 1 byte of data which is present in physical memory. So if there is a key, means if there is a virtual address, then there has to be a locker. Precisely saying, if there is a virtual page, then there exists a corresponding physical page, and that physical page may be on disk or it may be on memory. So suppose that a process virtual address space contains 5 virtual pages, right? And we already know that virtual pages are arranged in contiguous manner. Now if there are 5 virtual pages, then there exist 5 physical pages which may be stored in some non-contiguous frames in main memory. And you can see that there is a one-on-one relationship between a virtual page and a physical page. For every virtual page there exists a physical page. So you can see that virtual page P3 has physical page P3, virtual page P2 has physical page P2, and so on. So remember, these are the physical pages, and physical pages are nothing but they are a snapshot of the frames of main memory. So these physical pages may be present in some frames of physical memory or may be present on disk. But one thing is clear, that for every virtual page of a process, there exists a physical page. And it makes sense because you need actual physical memory to store data. Virtual pages are only collection of virtual addresses and they do not store any data. Corresponding to those virtual addresses, there exists a physical page, and on those physical page actually you store data. So as simple as that, if virtual page is a key, then physical page is like a locker where you kept your data items. So a typical virtual page looks something like this. Once again I am stating, virtual page is just a collection of virtual addresses. So A1, A2, A3, A4 up to A8 are like virtual addresses, and actual data is stored on the corresponding physical page. And you can see that physical page stores 1 byte of data corresponding to 1 virtual address. So if there are 8 virtual addresses in virtual page, then there exist 8 data items, each data item being a data of 1 byte in physical memory. So in this example, you can say that using virtual address A3, you can access 1 byte of this data item. Now going forward, you can see the diagram on the right hand side represents the virtual address space of a process in execution. So physical pages are created or destroyed as process uses or frees corresponding virtual pages during the course of its execution. So you can see that suppose this process is in execution, then corresponding to virtual pages which are in use, operating system will create physical pages. So for virtual page P0, physical page P0 will be created by the operating system. So it is this physical page which will actually store the machine code instructions of the process which is in execution. Similarly, the process virtual address space has a region called initialized and initialized data segment. So corresponding to these virtual pages, physical pages P1 and P2 will be created by the operating system. The actual initialized and initialized data segment will reside on these physical pages. So in this example, the physical page P0 and P1 and P2 will be created by the operating system as soon as you execute this program. The reason being that code segment and initialized and uninitialized data segment of a process are mandatorily created as soon as the process starts its execution. Now suppose your process requests some dynamic memory using malloc. So the operating system will create a virtual page and assign it to your process. Now corresponding to the virtual page P3, operating system also create a physical page P3, right? Similarly, if the process requests more memory from the operating system, the operating system will assign the virtual page P4 to the process. And corresponding to the virtual page P4, the operating system also create a physical page P4. And it goes on. So operating system allocates or releases the virtual memory and hence the corresponding physical pages in units of page size, which is 4096 bytes. So thus, if you request malloc 10, it may not result in creation of new physical or virtual page if topmost virtual page in heap segment of the process virtual address space still has 10 bytes of memory to satisfy the malloc request. So it is as simple as that.